Hello friends, welcome to my channel of learning microservices using .NET. So in last class we saw like our simple web API, like how we deploy the container in the Linux operating system in the completely different environment where we did not have installed any .NET runtime, and our application then from inside a container, and we successfully launched that. So if you want to see the details, you can check out my previous video, I think video number 2 of this series. So yeah, that's done. So today we will be focusing on the Docker file, optimization of the Docker file. Okay, so as you remember, like we are using the same Docker file for last two classes. So and we see like when we generate the image from the Docker file, so size was very big. So here I created this image, I think, yeah, 4 days ago, and the size we can see it is a 1.2 GB. Okay, so definitely there is something missing in this Docker file. Okay, it's not optimized properly. So today we will work on optimizing this Docker file. So let's start on this. So here we can see in the line number 2, here we are using the image, like we are using the single image which is used for building as well as running this application, this web API. Okay, and like what we are doing, we are creating an app directly, a working directory called app. Okay, and we are copying everything from our project, I mean from this solution, to this app folder. Okay, we are copying everything. Everything means everything, like if you see the controller file or model or app setting dot or program dot cs or whatever the DLLs are created inside the bin folder of this project. So those everything are copy inside, see, we can see the bin folder, right? So that everything is copied, all the DLL exes are copied in the app directory. Okay, and after that we are publishing this and keeping it inside the out folder, and we are launching our application from the out folder with the this DLL. Okay, so that's perfect. But here what we are doing, like we are copying everything, right? But in production environment, when we work real time, like this is not the way we should write the Docker file. So okay, in the first class I wrote this to make you understand the basic concepts, but today we will try to improve this Docker file. Today we will try to optimize this Docker file. Okay, so once we optimize, so we can see like the size will not be 1.2 GB. Okay, we should not have a simple project, simple API which have the 1.2 GB of the size. It should not be, it's not acceptable in the production environment. Okay, perfect. So let's start working on the optimization of the Docker file. So guys, I have written this piece of code in order to optimize the Docker file. So I have not deleted the old content, I am just keeping it as a comment. So I am commenting this. So I have commented the old content, old Docker file content. I have not removed. Why? Because it will be easy for you to compare line by line, like what is there new in the new Docker file and what was the old Docker file. So it will be easy for you to compare in the single same screen. So that's why I'm not deleting the old content. And here I have commented it, so this will not take effect. Only this will take effect from the line number 21. So this is our new Docker file for this application, for this test API application microservice. Okay, so okay, so let me try to explain here one by one. So guys, first of all, what we are doing is like we are having, like we need a image, right? So as we know, like in Docker or in the microservices world or in the containerization world, everything is image. Okay, so we are using the Microsoft Container Registry image to build our application first. Why? Because if we not build our application, we cannot run our application. So for building, we are using this image. Okay, so then what we are doing, we are same thing, like we are creating a app uh, directory, and we are copying everything from our project to app directory. Then we are running the .NET restore, and then we are publishing our project. Where we are publishing? We are publishing inside the out folder. That means inside app/out. Okay, so now our all the published file is there inside the app/out. Okay, so now next thing what we are doing, so please focus here, guys. So this thing is the new line here. So what we are doing now, our project building is done, build is done. Now for the runtime, we are taking another image, same from the Microsoft Container Registry. We are taking the another image to provide the runtime. So like, see, once we got the product, executable product, so definitely we don't need this build image. Okay, why to keep this heavy build image if it is of no use at this point of time? So when it has given its product, when it has given its output DLL or exe whatever, so next thing is we need the runtime, and this runtime we have taken from the microsoft.com. Okay, and now what I am doing, like I am creating a new folder. Okay, last time till whatever we have done, that was inside the app folder, inside the app out folder. Okay, so now what I am doing, I am creating a TAPI, test API folder inside the Docker image itself. Okay, inside Docker image itself I am creating a folder called TAPI, and see the very crucial point, line number 34. So what I'm doing here, I'm copying everything from build environment. Okay, so what is the build environment? So this is the tag which I have given here while importing the build image. Okay, so this is I am referring as a build environment. So I'm copying everything from build environment. So till this point I am telling Docker, okay, be ready to copy. From where we have to copy? Now from build environment we have to copy. Where inside the build environment? Now inside the build environment there is something called app, and there is something called /out, /app/out. So first go to build environment, and in the inside that build environment you will find something called app/out, and that you have to copy everything from app/out to current location. So what is the current location here? The current location is TAPI. So now from this environment, from this location, from this path, everything will be copied in TAPI folder. Okay, so this is the game changer, guys, this line. Okay, so what it is doing, it is whatever the output has been generated by the build, it is taking only that output which is needed to run the web API inside the .NET runtime. Okay, and it is copy here in the local path, so in the TAPI folder, and same thing from here. So now we are mentioning the port number 7777, and we are exposing the port number, and we are now running the application using .NET command test api.dll. So since, see, now what I have done, like I have copied everything inside the test API, right? So now the DLL also is present in a test API, so I have simply written test API DLL. But if you remember last time what I was returning, I was writing right out/test API. Why? Because everything was pushed inside the out folder of the app, and that out folder I was not copying anywhere, right? So it was as it is in the out folder. That's why I was using the out and then the DLL name to run the project. But here is not the case. Like here we have copied everything in a TAPI folder, and in TAPI folder we are launching the application. So now we can say, like in the app directory we had everything. Everything means everything, like controller, model, all those unnecessary packages which are really not required. But what we are doing, finally we are copying everything from this folder app out to our local folder. So it is having only the necessary DLLs or executables which is running necessary to run the app. So now our Docker file is ready. So next I am going to build this Docker file. I will going to create the image, and from the image I can show you run the container. We will see the output, and after that guys I will show you like physically how this folder inside the images will look like. Okay, so okay, let's go ahead and create the image from the Docker file. So here I have the command docker build /t. Okay, so this is the image name. I am going to give prod sort -img v1. Tag name is v1 in the current context. So let me verify, do I have any? Okay, so in the images folder I have only single image which I created 4 days ago, and which is of size 1.2 GB. Now let's create this optimized image. Okay, so it is creating the image. Perfect. So image is created. Now let's see how it looks. So this is the image name, prod sort img tag v1, and see the guys, this size is 320 MB. Okay, so it is showing 35 minutes ago. Why? Because like before shooting this video I had done one workaround, like just a trial run, so that time it got created already. So that's why it is showing 35 minutes, so don't be confused for that. So but this is the since I have given the same name, so that's why it is showing the 35 minutes. So now the size is 320 MB. Okay, so it is, we can say like it's a 1/3 or 1/4 of the actual size. Okay, now let's quickly verify the create the container and verify the result also. Okay, so I am trying to create one container whose name is prod sort container. I am binding to this port number in my system 6930, and this is the port number which exports in the Docker file for that application, and this is my image name, prod sort -img v1, prod sort -img. Yes, so let's create this container and we'll verify the result. So container is created and it is running also. So okay, so now if we go to containers, so we can see prod sort container. Okay, so it is created, and let me try to call this in the same port number. What was the port number? It was 6930. Yeah guys, so see the same result we are getting what we got last time. So it's the same result. Okay, so perfect. So now we have successfully optimized our image and with the same output. there is no change in the output. So the only change what we have done is the we have optimized the Docker file, okay, and we have not taken the unnecessary files inside the working directory. And this concept is called multi-layered image, okay. So there is a concept called multi-layered Docker images. So here we are creating a layer by layer image. So in first layer, what we are trying, like we are trying to fetch the build image and we are building the project. And once the build outputs like DLLs and exes are ready, then we are putting this in the folder and we are fetching another runtime image and we are running our application. So by this what happening, like it is fetching only the required executables, not the other uh, unnecessary things. Okay, perfect. I hope this concept is clear so far. Now let's try to locate these folders, okay. So as we see, right, so I am telling you, okay, it's a working directory app. So inside app there is something called out, okay, and there is something called TAPI folder, okay. So like we can actually, this is a Docker image, okay. So Docker image, like it's not like our Windows file system. It's not like I will go to C drive on some folder and I can see the content of this app and out. It's not like that. Why? Because it's a Linux based system, right? So Docker image, we like the base image, like base operating system we have created as a Linux based system. And second thing, like we cannot see the Docker image content as a window file system style, okay. So it has some different commands to see, like there are some command line are available that you can type some command and you can see the content, like you can see the app folder, you can see the TAPI folder, like whatever folder is there inside the image. But like uh, apart from that command line, like we have a very easy solution. Since if you have installed the Docker desktop application, then you can easily see those files here from this application. It doesn't mean that those are present in your local system or your file system, C drive, D drive. It's not like that, okay. So let's try to see those files, okay. So let's first see for this optimized one, like which we have created. So see, okay, so first thing I am trying to tell you that okay, so we have created the final folder as a TAPI, right. So we should be seeing a TAPI folder, and inside the TAPI folder we can see the content, like all the DLLs and EXEs, okay. So let's go to this. So prod sort. So one more thing, guys, like image content we can see only when that image container is running. So if that container is not running, then we cannot see the file inside the image, okay. So make sure your image is running container, okay. So this go to containers. So pod sort container, this you can remember, right, like this one which I created. So let's click on this container. So you can see the log files here, like what are the logs. It is telling that it is listening on the port number so and so, root path is TAPI, and let's click on the files tab here. So here you can see, so final, like what are the final what is the final folder I created, a TAPI, right. So you should be able to see the TAPI folder here. Yeah, perfect. See, you can see the TAPI folder, okay. So inside the TAPI folder we have the necessary executables, like we have a DLL file application, this TAPI application, okay. So these all the necessary files, whatever is bare minimum required to run this project, run this application, this we can see inside the TAPI folder, okay. So just don't get confused, guys, with the file system. It's not in the file system, it's not somewhere in the C drive or D drive, it's just inside the Docker desktop. We can see this is the easiest way of seeing the files, since it is not the very major topic, or it's no one will ask this question in interview, okay. It is just for my curiosity Why? Because one day while working on this Docker, so I was very curious to see when I saw the Docker file. So I was very curious to see, okay, how this, where exactly this app folder is created, where exactly how we are transferring from one folder to another folder, where is the destination. So I was very curious to see. So by doing some research and all the searchings, then I found some command line tools. But the command lines are also fine, but I also find the easiest tool is the Docker desktop. So through Docker you can easily click and you can see. So yeah, like here we can see all those things. These are the very bare minimum things. Okay, okay, fine. And now let's discuss about the old one. So since here we have not like we have not moved the executable content to the final destination folder, so we have everything we have maintained in the single folder itself, in the app itself. So everything is inside the app folder. Okay, so if I will go to the container of this image, I think 4 days back I created, right? So let's go and see this. So this is the image, product test image, which is a 1.2 GB. And for that, if I will go to the containers, this is the container. Okay, let me click on this and let me see the file. So here we can see the app. Inside the app, see, here we have out. Okay, so this is the exact folder. Actually, inside the app, this is what the exact folder where we have the actual content, bare minimum content. Okay, but what we have done in this file, see, this is very non-optimized file. Okay, so we have copied everything in the app. Okay, and we have copied the executables in the out folder. Okay, but in the final touch, like we have not copied the bare minimum things in a final some destination folder. Okay, so that's why, since we have not set, like here we set, right, a destination folder and destination work directory, so like that we have not done here. We have maintained the single work directory and single everything. Okay, so that's why you can see here. So whatever the bare minimum things are there, it is in the out folder. Let's compress this out folder. Apart from C, all the other things, bin, inside the bin, debug, all the DLLs and all the dependency which are not exactly required to run this application. See, I have the application file, I have the controller file. Okay, this is it should not be going to the production system. Your coding file, it should not be going to, right? So, and controller, see the model files also there, so it should not be going, right? Our actual file is out folder, where we have the bare minimum things, but not all other files. Okay, so this is, we can say, is an example of unoptimized, non-optimized Docker file. But here what today we created, that is the optimized one. Okay, so today what we have created is the optimized. Okay, and I think for today I'm done. I think like all the concepts are clear. So today I explained two things. One is the optimization of a Docker file, that is also called the multi-layered Docker file. Okay, multi-staged Docker file. Okay, and second thing is like locating these folders inside like image, how exactly it looks like in the image, not in the file system, Windows file system, but inside the image with the help of the Docker desktop. So I hope you like this video, guys. So that's all from my side today. If you like my video, please like this video, subscribe to my channel, and share this with your friends. Thank you very much.